All right, so on page 7, this is adding and subtracting with radicals, and you can only add or subtract radicals if they have the same radicand. Okay, so we know that the radicand is the number that's under the radical sign. So if you take a look at question number 1, so first thing I always look for first is look at the radicands, the number under the radical, and I make sure it is in simplest form. Okay, that means it doesn't have any perfect squares as a factor. 6 does not, so it's already in simplest form. And so I have 3 rad 6 minus 2 rad 6. And you don't add or subtract the radicands, you only add or subtract the outside numbers. So if I have 3 rad 6s and I take 2 rad 6s away, what is 3 minus 2? 1. And you don't really say 1 rad 6, we just say rad 6. So it's understood like there's an invisible 1 here. But you don't need to write it. So I'm going to go to number 2, and that's all you actually do for that. I'm going to go to number 2. I'm going to look at the radicands, and I can tell they are not in simplest form because I know 20 has a perfect square in it. 4 times 5 is 20, and 45 has a perfect square in it. 9, because 9 times 5 is 45. So what you're going to do is take your calculators. I'm going to let you do that, and you're going to hit your y equals key. You're going to put in 20 divided by x squared. So we did this lesson the last time, and then you will look in the y column and see where you have that last whole number. And if someone can tell me what they have on their calculator. Now, I'm going to do it by hand, okay, but you should definitely have the same thing I have. So I'm just going to break the 20 down to 4 times 5. I'm going to break the 45 down to 9 times 5. So when I pull this out, the perfect square out, you should have 2 rad 5 on your calculator. How many people saw that? All right, great. And when I take out the square root of 9, you will have 3 rad 5. So if I have 2 rad 5s and I add 3 more rad 5s to it, I have a total of 5 rad 5. So you only add the outside numbers. Okay. Now, you might ask, well, what happens if, so what if had happened if I had 2 rad 5 plus 3 rad 6? Then that would have been your final answer, because you would not be able to combine them together because they do not have the same radicands. So I want you to know that you're not going to always end up with just the same radicand all the time. And if you don't have the same radicands, you just simply write each one individually. Okay? All right, let's take a look at number 3. You can do this on your calculator, or I'm going to do it by hand. Okay, so a perfect square in 54 is what? Does anybody know? What times what gives you 54, and one number is a perfect square? Yes. 6 times 9? All right, 6 times 9. And 4 times 6. And again, if you can't do those factors like that, then by all means, use your calculator. I'm going to take the square root of 9 out, which is 3. I'm going to multiply it by the negative that's out there, so that's negative 3 rad 6. Here, I'm going to take the square root of 4 out, which is 2. I'm going to multiply it by the 3 that's there, so that's going to give me 6 rad 6. So if I have a negative 3 and a negative 6, I have a total of negative 9 rad 6. All right, any questions so far? All right, so we just did 45 up here. So I'm just going to say 3 rad 5. I'm going to multiply this 3 here by the 3 that's on the outside. So that's going to give me negative 9 rad 5. And I'm going to take 3 rad 5s away. So how many rad 5s do I have? Negative 12 rad 5. Okay, negative 9 and negative 3, you add them together. On page 8, we're going to start with question 15. And this is where, and we really kind of did this earlier in the year when we solved all the different types of equations and equations that have radicals in them. So to undo a radical, because you know equations is all about undoing what's there. So the opposite of a radical is squaring it. Like the opposites of addition and subtraction, opposite of multiplication division. Well, the opposite of a square root is squaring. So what you do is you square both sides. Okay, square the 9. So you square both sides of the equation. And what happens, that eliminates just the radical itself, and you're just simply left with what's under the radical. Well, obviously, when you square 9, you get 81. Okay, 9 times 9. All right, but when you square the radical, you just end up with the radicand, what's under there. That's it. It just really makes the radical disappear. So we're going to do the same thing over here. Going to square that side. So this is the easy part. Square that side. So when I square the radical, it just makes that go away. And I end up with just r minus 10. And then I square the 2. I get 4. 2 times 2. And then you just solve it like you would any regular, because it is a regular equation. Okay. All right, so let's do 17. Same thing. Square both sides. That's how you undo the radical. So I'm going to have 100. 10 times 10 equals 25x. It just drops the radical sign. Divided by 25. So 100 divided by 25 is 4. Okay. Now, in 15, 16, and 17, notice that the radical was already on one side of the equation by itself. In this problem, I have a -3 over here with the radical. So the very first thing you always have to look for is to make sure you isolate the radical. So that means, isolate means the radical has to be on the side of the equation by itself before you start squaring. Okay, so I'm going to take a look. I see I have -3 times the square root of 4n minus 4. So how do I get rid of something that's being multiplied? Divide. So I'm going to divide by the -3 on both sides. So that takes care of getting rid of that -3 over there, because -3 divided by -3 is 1. And then I'm left with the square root of 4n minus 4. And what is -18 divided by -3? +6. So now I'm ready to square both sides. So I'm going to square both sides. So that drops my radical sign. And 6 times 6 is 36. Okay, I'm sorry about that. And you guys should be able to solve it from there. Okay. All right, I'm going to move on to question number 20. So in question number 20, this is being added. This says +7. So how do you think I'm going to get rid of the +7? Subtract 7. Okay, so I'll have the square root of 5v plus 5 equals to 5. Then we can square both sides. So that's going to give me 5v plus 5 equals 25. And again, you can continue solving from there. Okay. So you'll go ahead and follow your calendar. Like I said, the only part you're not doing is the dividing part of it.